Hey everyone, this is Miss Afric, and today we are going to be talking about something called piecewise functions. But before I get into what those actually are, let's remind ourselves about some regular functions. Alright, right here it says review, evaluate the functions for the given values, and it gives us two functions. Remember, we would call these functions f of x equals negative 3x plus 2, and g of x equals x squared minus x cubed. So in number 1, where it says f and then 2 in parentheses, remember we say that as f of 2. And what that's saying is in the function f, plug 2 in for x. Alright, see how they're taking each other's spots? So in order to evaluate this, I'm going to take my function f, but instead of x, I'm going to replace it with a 2. And notice how I'm using parentheses. I always use parentheses when I'm substituting numbers in. So that'll give me a negative 6 plus 2, which is a negative 4. So now I know f of 2 equals negative 4. As easy as that. Alright, let's go through one more together. Number 2, it says g of negative 2. So this time, instead of f of x, I'm going to be using g of x. Alright, I'm going to replace negative 2 with the x in this function. So it's going to look like negative 2 squared minus parentheses negative 2 cubed. Again, don't forget those parentheses. So important. So negative 2 squared, that's like saying negative 2 times negative 2, which is positive 4. Minus, and then negative 2 cubed, well, negative 2 times negative 2 times negative 2 will give us a negative 8. 4 minus a negative 8 is really 4 plus 8. So we get 12. So that means g of negative 2 equals 12. Not so bad, right? Alright, I know you remember how to do this, so let's actually see you try some. Go ahead and pause this video and take care of numbers 3 and 4 on your own. When you unpause it, you can take a look at my answers and see if you did them right. Alright, so pause it right now. Alright, well, I hope you really paused it and tried these two problems because I think you should have been able to do them. For f of negative 5, we get the value 17, and for g of 0, we get 0. Alright, if you had questions on that, I would go back and remind yourself. This was from an earlier video. Now we're going to actually move into piecewise functions. Okay, piecewise functions are just like normal functions, but instead of just one equation, piecewise functions, like these two we see here, will have multiple equations. These two specific examples have two pieces, or two equations. Alright, so for these problems, we're going to be evaluating just like we did earlier, but instead of evaluating in a normal function, we're evaluating in a piecewise function. And what that means is we have to be really careful about what it actually says. So in this f of x function, notice how it says f of x equals 5x minus 1 if x is less than negative 2. And then it also says f of x equals x minus 9 if x is greater than or equal to negative 2. So they're giving us these kind of qualifying statements, right? These equations are only true if our x value satisfies these inequalities. So for evaluating, we really need to double check that. So let's try number 5. It says f of negative 5. So what we need to ask ourselves is negative 5 less than negative 2, or is negative 5 greater than or equal to negative 2? Well, negative 5 is a more negative number than negative 2, which means it is less than negative 2, so we're going to use this equation. So to evaluate it, I would plug it into just that equation. 5 times negative 5 minus 1. We could type that in our calculator or do it by hand. That should just give us, oops, I already wrote that. 5 times negative 5 is negative 25, minus 1 is negative 26. And there's our answer. Notice how I'm not plugging it into both of them. I gotta pick which one I plug it into. You should always only plug it into one. Alright, number 6, we got f of 5. So again, we ask ourselves, is 5 less than negative 2, or is 5 greater than or equal to negative 2? Well, 5 is bigger than negative 2, so we're going to use this equation. So I plug it in. Instead of x, it'll be a 5 minus 9. And 5 minus 9 should be negative 4. So there's our answer. Alright, so remember, again, piecewise functions, the only difference is we have multiple equations, so you got to figure out which one our x value fits for. Alright, in this second one, h of x equals 1/2 x minus 10 if x is less than or equal to 6, and h of x equals negative x minus 1 if x is greater than 6. So, once again, take a look at number 7. H of 10. That means x is 10. So is 10 less than or 6? I don't think so. Is 10 greater than 6? That sounds better. So we'll use that equation. Instead of x, I will plug in 10. Make sure you don't lose that negative sign. Negative x minus 1. And this should give us negative 11. Alright, let's try number 8 then. H of 6, so that means x is 6. So, is 6 less than or equal to 6, or is 6 greater than 6? Well, 6 is equal to 6, so you want to find the one that has that little bar underneath, because that means equal, and that'll be this one. So, if I plug it in, we've got 1/2 times 6 minus 10. 1/2 of 6 is 3, and 3 minus 10 is negative 7. Alright, so with evaluating, you really just got to focus on some key things and really ask yourself, which equation are you using? Okay, write that down. Which equation are you using? That way, if you forget, you can look back at this question and say, oh yeah, duh. Okay, it should always only be one of them. Never using more than one. Otherwise, it wouldn't be a function. Alright, go ahead and flip your page over and let's take a look at some actual graphing problems. Alright, we're just going to do a couple examples today and you'll see a few more examples in the video tomorrow. So, graph the following piecewise functions. Alright, once again, we've got two pieces here. So this says f of x equals 4 if x is less than or equal to negative 3, and x plus 6 if x is greater than negative 3. What I like to do is I like to kind of write this y equals part here, which is the same thing as f of x, but sometimes we forget that. So I write y equals so I can clearly see it. Now, what I want you to notice when we graph this is we're going to have two different pieces, and they're going to be separated by this boundary. Okay, notice how it's at negative 3. So you can kind of imagine, I'm going to draw this on the graph, that there's like a boundary line at negative 3. And half of our graph is going to occur on one side of that boundary line, and the other half is going to occur on the other side. Now, in order to get those two sides, we're going to use tables. So I'm going to set up a table for each one of my equations. So x, and then my first equation is y equals 4. And I'm going to set up a table for my second one, x, and then y equals x plus 6. So let's start with our first equation. Alright, when we pick x values for our table, the very first point we pick should always be our boundary point. So see how it says x is less than or equal to negative 3? That means the first x value I'm going to pick is negative 3. Now, just because it's a boundary point doesn't necessarily mean it's on the actual line. So you have to be careful here because we need to figure out whether that point is going to be a closed point or an open point. And what tells you that is this symbol right here. When that equal sign's there, that tells us that this boundary point is going to be closed. If it didn't have the equal sign, it would be open. Okay, now let me get rid of some of that writing just so you don't get too confused. Alright, if x is negative 3 and my function is y equals 4, that means y is going to equal 4. So there's my first point. Negative 3 comma 4, and it should be a closed circle. Now every other point that you get in your table, those are all going to be closed. The only point you have to check for in terms of closed or open is the boundary point. Alright, for my other points in this table, I just need to be careful that I abide by this rule. X must be less than or equal to negative 3. So I could pick x values like negative 4 or negative 6. Alright, or negative 10. I could go, as long as it's less than or equal to, it works. Now, if x is negative 4, my function is y equals 4, so that means y will still be 4. And if x is negative 6, once again, y is going to be 4. So there's a couple more points. Negative 4, 4, negative 6, 4. Okay, and just notice the pattern you've got. It looks like this is going to be a horizontal line. So there's half of our graph. Now we're going to do the same thing with our second table. And once again, I'm going to start at my boundary point. And my boundary point here is also negative 3. So my first x value will be negative 3. And I have to check to see if it's closed or open. That's what the inequality symbol tells me. There's no equal sign under there, so this is going to be an open boundary. And then to get my y value, this time I'll actually have to plug it in for x, because there's an x in this equation. So y equals negative 3 plus 6. Negative 3 plus 6 is a positive 3. So I'm going to have an open boundary point at negative 3 comma 3. Now the other 2 points I get will be closed because they're not boundary points. Anything that's not a boundary point is closed. And I just need to make sure that I pick x values that are greater than -3. So I could pick -2. I could go bigger and pick 0. Alright, then to get the y values, I just plug them in. -2 plus 6 is 4, and 0 plus 6 is 6. So now I should have a point at -2, 4, and 0, 6. And once again, follow that pattern and draw your line. And that's it. There's our piecewise function. So I know it seems kind of complicated, but as long as you remember your 2 tables, you should be able to set up those points. Alright, let's take a look at this function over here in number 10. That one looks crazy complicated, right? But don't get too freaked out. This piecewise function just has 4 pieces, right? Y equals 1, y equals 2, y equals 3, y equals 4. However many pieces there are, we're going to set up a table for each one of them. So here's a table for the first piece, a table for the second piece, a table for the third piece, and lastly, a table for the fourth piece. Now, even though this one looks more complicated, the problem is actually making it a little easier for you, because right here you can see we've actually got 2 boundary points for every function. Well, that's okay, because that just means that those are going to be the 2 points that I use in my table. So for this first function, my 2 x values are going to be -4 and -3. Alright, and then since they're both boundary points, I do have to figure out if they're closed or open. Right here, I see that that has the equal sign, so that means that -4 is going to be closed. And right here, I see that that has no equal sign, so that means -3 is going to be open. And then I check my y equals. Y equals 1, so I don't have to plug anything in. I know y is 1 for both of them. So to get this started, I have a point at -4, 1, and it's closed. And I have a point at -3, 1, and that one is open. Draw the line in between, and there's my first piece. Alright, now I'll do the same thing with these other 3. I'm going to go a little faster with them to make sure we can see the entire graph. Now again, for these, I'm going to pick those 2 boundary points. This time it's -3 and -2. For -3, once again, you should notice we've got kind of a pattern here. Right, all of those first boundary points are closed, and all of the second ones are open. So that'll be closed, and that one will be open. And my y value for both of these is just 2. So I've got a point at -3, 2 that's closed, and -2, 2 that is open. Alright, keep going for this third one. My 2 points are -2 and -1. Once again, closed and open. And then my y value for both of them will be 3, because it's y equals 3. So -2, 3, that's closed, -1, 3, that's open, and connect the dots. And now just one more. My last one should have x values of -1 and 0, with -1 being closed and 0 being open. And my y value will both be 4. So -1, 4, that one's closed, and 0, 4, that one is open. And there's my function. Now this one might look a little bit strange. This is actually a special kind of piecewise function. It's called a step function, because see how they kind of look like steps? So this one is just called a step function. And it looked complicated, but it actually was relatively straightforward. Alright, let's quickly just take a peek at 11. We'll have to finish this one in class, but just to take a peek of it, it says write the equation for the given graph of a piecewise function. Notice how there are 2 pieces? That means my function should just have 2 pieces. One right here, one right there. Another thing I want you to notice is this boundary line. See how there's a boundary line and it looks like it's at x equals 1? That means when we write out our equations, it should be if x is less than or equal to 1 and if x is greater than 1. See if you can figure out what those equations of each of those pieces are. If not, don't worry. Your teachers will talk about it in class the next day. If there's anything from here you still feel a little iffy on, please go back and rewatch, because piecewise functions can be kind of challenging. Otherwise, just write down any questions that you have and be prepared to ask them in class. Can't wait to see you then.